Hello everyone, welcome back to the channel. In today's video, we're diving into some really useful Python functions, map, filter, and reduce. If you've ever wondered how these functions work, when to use them, and what makes them different, then stick around because I'll be breaking them down in a super easy and practical way. These functions are incredibly powerful tools when working with data processing in Python, and understanding them can make your code more efficient and cleaner. Whether you're preparing for coding interviews or looking to improve your Python skills, this video is for you. So let's get started by exploring how each one works step by step. Part 1, Introduction to Map, Filter, and Reduce. Let's dive into the three key functions map, filter, and reduce and break them down in a really simple way. Starting with map, imagine you've got a bunch of items going down an assembly line. Each item gets processed in the same way, like putting a sticker on every box. That's essentially what map does. It takes a function and applies it to every single item in a list, tuple, or other iterable. For example, if you wanted to double every number in a list, you'd use map. It's especially cool because it can work on multiple iterables at the same time, like adding corresponding items from two lists. You get back an iterator with all your transformed results, which you can convert into a list or whatever you need. Now let's talk about filter. Think of this like a sieve is going to sort through a collection of items and only keep the ones that meet a certain condition. For example, if you have a list of numbers and you only want the even ones, filter will run each number through your condition. In this case, is this number even, and toss out the ones that don't pass. The key here is that filter only returns the elements where your function gives back true. It's super handy when you need to filter out unwanted values based on some rule. Finally, we've got reduce. This one is a bit different. It's not about transforming or filtering, but about combining everything into one final result. Picture a snowball rolling down a hill, gathering more snow as it goes. That's reduce. It starts with the first two items, applies a function like adding or multiplying them, and then keeps applying that function as it moves through the rest of the items one by one until you've got a single result. It's great for things like summing up a list of numbers or calculating the product of a set of values. Just remember, reduce needs to be imported from the functools module, unlike map and filter. So that's the gist of these three functions. Each one serves a unique purpose, and knowing when to use them can make your code cleaner and more efficient. Let's now jump into some examples. In this example, we're using the map function to transform a list of numbers by doubling each value. We start by defining a simple function called double x that takes a number as input and returns its double value. Next, we have a list of numbers 1, 2, 3, 4. We want to apply the double function to each number in this list, and that's exactly what map helps us do. When we call map double numbers, Python applies the double function to every element in the numbers list, but instead of immediately returning the transformed values, it gives us a map object, which is an iterator. To see the results, we convert this map object into a list using list double, which gives us the final output 2, 4, 6, 8. In short, map allows us to process each item in the list by applying a function and easily return the transformed data, making it a powerful tool for element-wise operations. In the next example, we're using the filter function to select specific elements from a list based on a condition. The condition is defined by the function is underscore even x, which checks whether a number is even. It returns true if the number is divisible by 2 and false otherwise. We have a list of numbers 1, 2, 3, 4, and we want to keep only the even numbers. By applying filter is underscore even numbers, Python goes through each element in the list, applies the is underscore even function, and includes only the numbers that return true. Just like with map, filter returns an iterator, so we convert it into a list using list even underscore numbers to get the final result 2, 4. In summary, filter is perfect when you want to sift through a collection of items and keep only those that meet a certain condition, like filtering out odd numbers in this case. In the next example, we are using the reduce function from the functools module to combine all elements of a list into a single value. The reduce function takes two arguments, a function in this case, multiply x, y, and an iterable the list of numbers 1, 2, 3, 4. The multiply x, y function simply multiplies two numbers together. The way reduce works is by applying this function cumulatively to pairs of elements in the list. First, it multiplies the first two elements, then takes the result and multiplies it by the next element, and so on until all elements are combined. Here's how the reduce function processes the list step by step. It starts by taking the first two elements 1 and 2 and multiplies them, resulting in 2. Then it takes this result 2 and multiplies it by the next element 3, giving 6. Finally, it multiplies 6 by the last element 4, which produces the final result 24. So the entire list 1, 2, 3, 4 is reduced to the single value 24 through this cumulative multiplication process. The final result of multiplying all the numbers together is 24, which is printed out. Reduce is particularly useful when you need to perform cumulative operations on a list, like finding the product, sum, or other aggregate values. In this case, it reduced the list 1, 2, 3, 4 to a single value 24. Part 2, Simple Differences. Alright, let's see the simple differences between map, filter, and reduce in tabular format. This will help us easily compare how each function works, what kind of input they expect, and what output they produce. By laying it out side by side, we'll get a clearer picture of when to use each one in your Python projects. So let's dive into the table. Definition. Let's start by looking at the definition of each function. Map applies a function to every item in an iterable like a list and returns a new iterable containing the results. For instance, if you have a list of numbers and want to double each one, map will apply the doubling function to each number and return a new iterator with the double value. On the other hand, filter is designed to apply a function to each item in an iterable and only returns the items where the function returns true. This is useful when you want to filter out unwanted elements based on a condition. Reduce works a bit differently. It takes a function and applies it to pairs of items in the iterable cumulatively, reducing the entire iterable to a single value. For example, you might use it to add all the numbers in a list together. Purpose map is used to transform the elements in an iterable. It's ideal when you need to change every element in a consistent way, like converting all numbers to strings or applying a calculation to each element. Filter, as the name suggests, is used to filter elements from an iterable. It's particularly useful for extracting only the elements that meet a specific condition, like selecting only positive numbers from a list. Reduce is designed to reduce an iterable to a single value by applying a function repeatedly to pairs of elements, such as summing or multiplying numbers. Input. Consider the input each function requires. Map takes a function and one or more iterables. You can pass in multiple iterables and map will apply the function to corresponding elements from each iterable. Filter takes a function and a single iterable. It applies the function to each element, keeping only those for which the function returns true. Reduce also takes a function and a single iterable, but the function must take two arguments as it applies the function cumulatively across the elements. Output. The output of these functions differs as well. Map returns a map object, which is essentially an iterator. You'll need to convert it to a list or another structure if you want to use the results immediately. Similarly, filter returns a filter object, which is also an iterator. Again, you'll need to convert it to a list or tuple to use the filtered results directly. Reduce, on the other hand, returns a single value like the sum or product of all elements in the iterable. Type of function used. Map works with any function that operates on a single element. It could be a simple mathematical operation or something more complex. Filter requires a function that returns true or false, as this function is known as a predicate. The elements that evaluate to true are kept. Reduce works with a function that takes two arguments and applies it iteratively to the entire sequence, reducing it to a single value. Return type. For the return type, both map and filter return iterator. You can convert these iterators into lists or other structures as needed. Reduce, however, returns a single value once the reduction is complete, so there's no iterator involved. Data structure output. Regarding the data structure output, both pass map and filter return lazy iterators, which means they only compute values when needed. You can convert these iterators to lists or tuples for immediate access to the results. Reduce, on the other hand, doesn't return an iterable, it computes a final value from the iterable. Lazy evaluation. In terms of lazy evaluation, both map and filter use this approach. Values are generated only when requested, which makes them efficient for working with large datasets. However, reduce does not use lazy evaluation because it computes the result all at once. Number of arguments. The number of arguments differs as well. Map can take multiple iterables and apply a function to corresponding elements from each one. Filter, however, takes only one iterable and applies the function to each element. Reduce also works on a single iterable, but it applies the function cumulatively to all elements. Common usage. For common usage, you'll often use map when you need to transform or modify each element in an iterable, such as doubling a list of numbers. Filter is useful when you need to remove unwanted elements, like filtering out negative numbers. Reduce is typically used for operations like summing or multiplying elements to produce a single result. Part 3. Hands-on examples for simple differences. Now, let's explore the simple differences between map, filter, and reduce with some practical examples. These examples will showcase how each function works, starting with basic scenarios to demonstrate their core functionality. Whether it's transforming a list of numbers, filtering based on conditions, or reducing elements to a single value, these hands-on examples will help you see how each function behaves in real-world situations. Let's jump into the code and see these simple differences in action. Example 1. Using map with multiple iterables. In this example, we use the map function with two iterables, list1 and list2, to combine their corresponding elements. The function addX_y is defined to take two arguments, add them together, and return the result. When we call map add list1 list2, map applies the add function to each pair of elements from list1 and list2. For example, it first adds 1 from list1 and 4 from list2, giving 5. Then it adds 2 and 5, resulting in 7, and finally 3 and 6, resulting in 9. The result is a map object, which is then converted to a list to display the final output 5, 7, 9. This shows how map can handle multiple iterables simultaneously and apply a function to their corresponding elements. Example 2. Using filter with map. In this example, we combine the use of map and filter to transform and then filter a list of numbers. First, we define the function increment x to add 1 to each number. Then we use map to apply this function to each number in the list numbers, which contains 1, 2, 3, 4. After map adds 1 to each number, the transformed numbers become 2, 3, 4, 5. Next, we pass the result of map into filter to keep only the even numbers. This underscore even function checks if a number is divisible by 2 and only those numbers are retained. Finally, we convert the filtered result into a list, resulting in 2, 4. This shows how map can be used to first modify a list, and then filter can be applied to select elements based on a condition. Example 3. Using reduce for summation. In this example, we use reduce to sum all the elements in a list. The function addXy is defined to take two numbers and return their sum. We have a list numbers containing 1, 2, 3, 4, and we want to sum all of these values together. When reduce is applied, it first takes the first two elements, 1 and 2, and adds them together to get 3. Then it adds 3 to the next element, 3, resulting in 6. Finally, it adds 6 to the last element, 4, producing the final result of 10. Here's how the reduce function works step by step. First, it starts by taking the first two numbers from the list 1 and 2 and adds them together, resulting in 3. Then it takes this result 3 and adds it to the next number in the list, which is 3, giving a new sum of 6. Finally, it takes this cumulative sum 6 and adds it to the last number 4, resulting in the final total of 10. This cumulative process is what allows reduce to work through the entire list and return a single value, which in this case is 10. The final result is printed as 10, showing how reduce accumulates values across the entire iterable by applying the add function repeatedly. Part 4. Advanced and complex differences. Now let's move on to the advanced and complex differences between map, filter, and reduce. These more detailed distinctions will help us understand how these functions behave in different scenarios, including how they handle multiple iterables, performance considerations, and their roles in functional programming. By exploring these deeper aspects, you'll gain a stronger grasp of how to effectively apply these functions in your code. So let's dive into the complex differences. Primary function. The primary purpose of map is to transform each element of an iterable by applying a function. If you provide multiple iterables, it applies the function element wise across corresponding elements. In contrast, filter works by applying a Boolean function and returns only the elements that pass the condition, i.e., where the function returns true. Reduce, on the other hand, reduces the entire iterable to a single value by applying a binary function iteratively. It starts with the first two elements, then uses the result as an argument for the next element, and so on. Input structure for map: you can provide one or more iterables. If you provide multiple iterables, the function must accept multiple arguments to work in parallel across them. Filter takes only one iterable and applies the function to determine whether each element should be kept. Reduce also works with a single iterable, but the function must take two arguments as it reduces the elements pairwise. Iteration behavior: map applies the function to each element of the iterates and returns an iterator of the transformed values. With filter, the function is applied to each element and only those that pass the test where the function returns true are included in the result. For reduce, the function is applied cumulatively, reducing the iterable to a single value. Reusability of result: both map and filter return iterators, meaning that you'll need to convert them, e.g., into a list to reuse the results multiple times. On the other hand, reduce returns a single value, so you don't need to convert anything for reuse, the value is already there. Function requirement: the function passed to map can return any type of value and is applied to each element of the iterable. For filter, the function must return a Boolean value, true or false, and only elements where the function returns true are included in the final result. Reduce requires a binary function, meaning it must take two arguments and return a single value after combining them. Chaining behavior: you can easily chain map with other functions like filter or reduce to create more complex transformations. Similarly, filter can be used before map or reduce to limit the items processed. Reduce is typically used after map or filter to aggregate or summarize the processed data into a single result. Output type: map returns a map object and iterator which can be converted into a list or tuple for immediate evaluation. Similarly, filter returns a filter object which can also be converted to a list, tuple, etc. Reduce returns a single result instead of an iterable. Multiple iterables: map is flexible in that it can accept multiple iterables and apply the function element-wise in parallel across corresponding elements. Filter only works with a single iterable, and reduce also operates on a single iterable, reducing all elements down to one result. Flexibility in function design: map works with any function that operates on elements individually, while filter works with any function that returns true or false to determine which elements to keep. Reduce only works with binary functions, functions that take two inputs to perform cumulative reductions. Performance consideration: in terms of efficiency, both map and filter use lazy evaluation, making them efficient for large datasets because transformations and filtering are only applied when necessary. Reduce can be less efficient for large datasets as the function is applied cumulatively, which may require multiple function calls on the same data. Handling multiple iterables: map shines here by supporting multiple iterables, applying the function element-wise across all iterables in parallel. Filter and reduce can only handle a single iterable. Handling of none values: map works well with any function, even if it returns none. Filter may skip over elements where the function returns false, which includes none values. With reduce, none values need to be handled explicitly as they can cause errors when trying to combine elements. Combining with lambda functions: map is often paired with lambda functions for short, one-line transformations. Similarly, filter is commonly used with lambda functions for filtering elements based on a condition. Reduce is also frequently combined with lambda functions for cumulative operations like summing or multiplying values. Used with itertools: map often works with itertools for large-scale data processing and chaining operations. Filter can be combined with other lazy evaluation functions like itertools.islice to filter specific subsets of large datasets. Reduce can be used with tools like itertools.accumulate when multiple cumulative operations are needed. Function signature for map: the function should operate on individual elements or corresponding elements when multiple iterables are passed. Filter requires the function to return true or false to decide whether to include an element in the result. Reduce needs a binary function that takes two arguments and applies the cumulative reduction. Efficiency and memory usage: both map and filter are efficient with large datasets due to lazy evaluation. This means elements are only processed when needed. Reduce works on the entire iterable at once, which might not be as efficient for large datasets compared to map and filter. Use case for higher order functions. Map is best suited for applying transformation functions element wise to iterables. Filter is used for filtering out unwanted elements or selecting subsets. Reduce is ideal for combining or aggregating all elements in an iterable into a single result, such as calculating sums or products. Function application order. Map applies the function independently to each element of the iterable S. Filter checks the condition first and applies the function to decide whether each element should be included in the result. Reduce applies the function cumulatively, using the result of the previous function application as an input for the next one. Part 5, hands-on examples for complex differences. Now that we've explored the detailed differences between map, filter, and reduce, let's dive into some hands-on examples to bring these concepts to bear. We'll look at how these functions behave in more complex scenarios where they interact with multiple iterables, lambda functions, and real-world use cases. These examples will help solidify your understanding of how and when to use each function effectively. So let's get started with some code and see these powerful tools in action. Example 1, using map for transformation. In this example, we have a function called double that takes a single argument and returns that value multiplied by 2. We then create a list of numbers 1, 2, 3, 4, which we want to transform using the map function. When we apply map with double function and the list numbers, it processes each element in the list one by one. For each number, the double function is applied and the result is returned as a new value. These double values are stored in a map object, which is an iterator. Finally, to view the results, we convert the map object into a list and print the output. The double values 2, 4, 6, 8 are the result of multiplying each original number by 2, demonstrating how map can be used to efficiently transform elements in a sequence. Example 2, using filter for conditional filtering. In this example, we have a function called is underscore even that checks if a given number is even by returning true if the number is divisible by 2, i.e. x%20. If the number is not even, it returns false. We then apply the filter function to the list numbers, which contains 1, 2, 3, 4. The filter function iterates through each element in the list and applies this underscore even function to determine whether each number should be kept or discarded. Only the numbers that return true, i.e. the even numbers, are kept in the result. Finally, we convert the resulting filter object into a list to display the even numbers. In this case, the numbers 2 and 4 pass the condition, so the output is 2, 4. This example shows how filter can be used to selectively retrieve elements from a sequence that meets specific criteria. Example 3, using map with multiple iterables. In this example, we use the map function to add corresponding elements from two lists, numbers 1 and numbers 2. The lambda function takes two arguments x and y representing elements of numbers 1 and numbers 2 and adds them together. Here's how it works. For the first elements, 1 from numbers 1 and 4 from numbers 2, the result is 5. Then for the second elements, 2 and 5, the result is 7. Finally, for the third elements, 3 and 6, the result is 9. The map function creates an iterator that applies this addition for each pair of elements, and converting it to a list gives us the result 5, 7, 9. This example demonstrates how map can operate on multiple iterables at once. Example 4, using filter with map to filter even numbers after transformation. In this example, we first use the map function to add 1 to each element of the numbers list. The lambda function inside map takes each number, adds 1 and returns the result. Once this transformation is applied to each element, we pass the modified list to the filter function, which keeps only the even numbers by using the _even function. Here's how it works step by step. The map function adds 1 to each number in the list. 1, 2, 3, 4 becomes 2, 3, 4, 5. Then filter goes through this transformed list and retains only the even numbers, which are 2 and 1, 4. Finally, we convert the filtered result to a list and the output is 2, 4. This example shows how you can combine map and filter to first modify a list and then filter it based on a condition. Example 5, using reduce with filter to get the sum of positive numbers. In this example, we first use the filter function to select only the positive numbers from the list -1, 2, 3, -4, 5. The lambda function inside filter checks if each number is greater than 0, keeping only the positive numbers. After filtering, the list becomes 2, 3, 5. Next, we use reduce to sum the filtered positive numbers. The lambda function in reduce takes two numbers at a time and adds them together, accumulating the total. Here's how the summing process happens step by step. First, the numbers 2 and 3 are added together, resulting in 5. Next, this sum 5 is added to the remaining number, which is 5, giving a final result of 10. So, after the cumulative process of adding the filtered positive numbers, the total sum becomes 10. The final result is 10, which is printed as the sum of all positive numbers in the original list. This example shows how you can use filter to clean your data and then reduce to combine the results into a single value. And that's it. Those are the key differences between map, filter, and reduce. I hope you found this explanation helpful and now feel more confident using these functions in your Python projects. They're especially handy when you want to write clean, concise, and efficient code. If you enjoyed the video or learned something new, don't forget to give it a thumbs up, share it with your friends, and hit that subscribe button for more Python tips and tricks. Thanks for watching, and I'll see you in the next video. Until next time, keep coding and keep learning. Bye.